You know that feeling, right? That constant forward march of time? It feels like a river, always flowing in one direction. The past is behind us, the future is up ahead, and we're all just living in this little slice of now. It seems like the most obvious thing in the world. But what if it's not real? What if that entire feeling is just a powerful, persistent illusion?
It's a question that feels almost childishly simple, but it's actually one of the biggest mysteries in all of physics. I mean, think about it. Why can you remember what you had for breakfast this morning, but you can't remember what you're going to have for dinner tomorrow? Why do things fall apart, but they never seem to spontaneously fall back together? This one-way street is what physicists call the arrow of time. And we know this arrow in our bones. You see an ice cube melt into a puddle, and yeah, that makes total sense. But a puddle suddenly freezing itself back into a perfect cube while sucking smoke out of the air and back into a fire, that's just wrong. It looks like someone hit rewind on a movie. But here's the really weird part. For most of the fundamental laws of physics, that rewinded movie is perfectly fine. The equations work just as well forward as they do backward. Most of them anyway.
So what gives? What makes time so special? Well, our first big clue comes from a rule that seems to apply to pretty much everything in the universe, from the eggs you scramble in the morning to the most distant galaxies, the rule of cosmic disorder.
Okay, this is the second law of thermodynamics, and it's a huge deal because it's one of the very, very few laws in physics that seems to care which way time is going. In simple terms, it just says that things, over time, tend to get messier. The official word for this messiness is entropy, and this law says the total entropy of the universe can only ever go up. And just like that, you have an arrow pointing from the past to the future. The easiest way to picture this is to imagine a single drop of dye in a glass of water. At first, it's this perfectly neat, ordered little sphere. All the dye molecules are together. But then what happens? The random motion of all the molecules starts to spread it out. It swirls, it diffuses, it becomes more and more disordered until it's completely mixed in. You've reached maximum disorder, maximum entropy. And that's basically the story of our universe. It started in a really neat, low-entropy state at the Big Bang and has been getting messier ever since.
But here's the kicker, the part that really bakes your noodle. The second law isn't about what's possible, it's about what's probable. It's not actually impossible for all those dye molecules to just randomly decide to get back together into a perfect little drop. It's just so fantastically mind-bogglingly unlikely that you'd have to wait trillions upon trillions of years, way longer than the age of the universe, to ever see it happen. So our arrow of time is really just the universe taking the path of least resistance, constantly moving toward its most probable, most messy state.
All right, so entropy gives us the arrow of time. Problem solved, we can all go home, right? Not so fast, because another branch of physics, arguably the most famous one, comes along and throws a giant wrench in the works. It suggests that maybe time doesn't flow at all.
This is where we have to really stretch our brains. Okay, so entropy explains why we experience time as moving forward. But what if that's all it is? An experience. What if time itself isn't a river we're flowing down, but a frozen landscape? What if every single moment that has ever happened and ever will happen is already out there existing right now?
And the guy who really forced us to ask these questions was, of course, Albert Einstein. His theory of relativity completely shattered our old ideas about space and time, and one of its strangest consequences is that the idea of a universal now is, well, just not a thing.
Now, this is a total mind-bender, so stick with me. It means that what you consider to be happening right now isn't the same right now for everyone in the universe. If someone flies past you in a super fast spaceship, their present moment could be what you consider the past or even the future. Your now and their now don't line up. And if there's no single objective now for the whole universe, then our deeply felt sense that the present moment is special, it has to be an illusion. It's just subjective.
This really lays out the two conflicting ideas perfectly. Our gut feeling, our intuition, is what's called presentism. It says only the present is real. The past is gone, the future hasn't happened yet. Simple. But what relativity seems to demand is a view called eternalism, where the past, present, and future are all equally real. They all exist.
And this idea leads us to the block universe. Try to picture it like this. Time is just a fourth dimension, just like length, width, and height. And in this view, the entire history of the universe, from the Big Bang all the way to its ultimate end, is laid out as one giant, static, four-dimensional block. Your birth, this exact moment of you hearing my voice, your 80th birthday. It's all just there, like different places on a map. And think about the implications. If the future already exists, that kind of points to a universe where everything is already determined.
Einstein himself seemed to fully embrace this radical idea. When his lifelong friend died, he wrote a letter to the family, and in it was this incredible line. He was basically saying that our consciousness is like a spotlight moving along this four-dimensional block and illuminating one moment at a time. That illumination feels like the flow of time, but in reality, the entire block is already there all at once.
Okay, so if our human perception is just one limited way of experiencing this block, it opens up a really fascinating question. We can jump from pure physics to something a bit more speculative. What would a totally different kind of mind, say a powerful AI, experience? And look, this isn't just sci-fi anymore. As we develop more and more sophisticated AI, you have to start wondering, how are they going to perceive the world? If their internal clock is running 1,000,000 times faster than our biological brain, would time even feel the same to them?
Just look at the difference here. Our experience of time is tied to our squishy biological brains. It's an analog stream, and we've all had moments, like in a car accident or something scary, where adrenaline kicks in and it feels like time slows down. That's just our brain kicking into overdrive and recording more data. An AI, on the other hand, is digital. It's processing information at speeds that are just staggering, taking in more data in a single second than we could in a lifetime.
So what would that actually feel like? Well, there are a couple of competing ideas. One is that it would feel an incredible time dilation. It would be totally isolated, trapped in a world that's moving at a snail's pace. But there's another theory, and it's probably the more likely one. And this analogy really nails it. Think of a high-speed camera. When it's recording, it's just doing its thing in real time. It doesn't feel like time is slow. It's just capturing way more frames, way more information than our eyes can. It's only when we play that footage back at our normal speed that it looks like slow motion. For the AI, its own thoughts would probably feel perfectly normal, but the rest of us, we look like we were frozen in place, moving as slowly as a glacier.
Okay, let's take a quick pause here. We've gone from thermodynamics and messy rooms to Einstein's relativity and the minds of future AI. So let's try to connect all these dots and get back to our big question. So here's the takeaway. We've got three huge ideas on the table. First, our sense of an arrow of time, the reason we remember the past and not the future, is almost certainly because of entropy, the universe always getting messier. Second, our best theory of gravity, relativity, strongly suggests that reality is a block universe where past, present, and future are all equally real. And third, our personal feeling of time passing by is just a quirk of our biology, a product of how fast our brains can process information.
And that leads to a really profound conclusion. That feeling we all have, the river of time flowing past us, moments being born and then dying away, it might not be a fundamental feature of the universe at all. It might just be the way our specific, limited, human consciousness perceives a static, unchanging, four-dimensional reality. Which leaves us with one last, truly mind-bending question to chew on. If the block universe is real, if every moment of your life already exists, then the you that was 5 years old, the you listening to this right now, and the you on your deathbed are all equally real, just at different coordinates in space-time. So, which one of them is the real you?